In this tutorial, we cover function, a fundamental part of Go that help you organize and reuse code efficiently. Let's start by writing a simple function. So you already seen the main function in Go. Now we will start writing our own function. So let's write a simple one. Say func, say hello, and we can print out hello Go. And then we can try to run it. So say hello and say hello. And if we now run it in the terminal, go run main.go, we get hello Go 3 times. Functions can accept arguments and return values. And because Go is a typed language, you also have to specify the types. For example, we have a function and we call it add. And first argument, let's call it a, and it's of type int. And then we have a second argument, we call it b, and that's of type int. And then we have a return type that will also be a int. So we can write return a plus b. We can run it like this. So add, for example, 2, and then we can add 5. And let's also print out the results. If we run this, get 7 back. If you have multiple arguments of the same type, you only need to write the type 1 time. So we can simplify this by just removing this. And we are still saying like both a and b are of the int type. And if we run it now, we get the same result. In Go, function can also have multiple return values. Let's see how that would look like. We will create a new function and we will call it divide. And it will take 2 arguments, a and b, and we can set it to be float 64. And then for the return type, we set float 64 and error. And here we will do a check. If b equal 0, then it's not possible to divide the number. So we will return 0 as the first value, and here as the second return value, we will return an error. In Go, you can create errors by using errors dot new. And then you pass in the message of the error. So in this case, we can write division by 0 is not allowed. And if b is not 0, we want to return a divided by b. And the second return type, because here we don't have an error, so we can just return nil. And to use it, we will write like this. We will have 2 variables, so result, and then error. And here we will call the divide function, so divide. And then we can pass 2 values, so let's say 10 and 0. We can now do a check for the error. So if error not equal to nil, in that case we want to print out the error. So we can do fmt print line error, comma, and the value of the error variable. And in case there's no error, we just want to print out the result. So fmt print line result. It's a quite common pattern in Go that the last value that you return from a function is an error. You will often see in Go code that, for example, you call a function that returns some values and the last value will be the error, and then you will do like a check. Is there an error or not? So let's see what we get when we run this. And because we pass 0 as the second argument, we get error division by 0 is not allowed. Let's change this to maybe 2. So if we run it again, we will then get result 5. Let's walk through a bit more advanced example. So in Go, you can pass function as an argument to another function. We can start by creating a function and we will call it apply. And this function will accept a slice as the first argument of slice. And then the second argument, it will be a function. You can call it fn, and it will be a type func. This function will accept an int and it will return an int. And inside this apply function, we will loop over the slice. So for I and then v, we set that to be range slice, and inside the loop we will say slice index, and then we set it equal, and we will call the function that is passed, so fn, and we can pass the current value we are iterating over, so v. In case you have been coding in other languages, this might look familiar to you. It's basically a map function, and here we will create another function. Let's call it double, so func double. It will accept the int argument, so we will call it n int, and it will return an int. And inside the function, we will just say return n times 2. So let's now call it from the main function. We can start by creating a slice. So let's call it nums, and we set that equal to be an int slice. So 1, 2, 3, 4, 5. And we can now call the apply function, apply, and we pass the slice, so nums. And the second argument, we will pass the double function, double. And then let's print out the num and see what we get. So if we run this now, we can see that every value here has been doubled. So 1 is 2, 2 is 4, 3 is 6, 4 is 8, 5 is 10. So the apply function will loop over the slice, and it will call the function that we pass for every element and basically transform the slice. We could also change the double function to be something else. For example, let's create a new function, func, and we will call it square. This will also accept an int, and it will return an int. And then we will write return n times n. If we now, instead of passing double, we will pass square, and we run it. And we can now see in the slice, it's just the square of the number. Let's clean this up. We can also have something called variadic functions. Variadic functions allows you to pass any number of arguments. One example of that is the print line function that you used before. Let's create our own variadic function. So func, and we will call it sum, and this sum function will take any numbers of arguments. So we will call it nums, and we will set it to be dot, 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 and then int. So what's gonna happen here is that you can pass any number of int arguments, and then inside the function, Go will turn this into a slice. So inside the function, we can write total, and you can set that equal to 0. We will loop over nums, set underscore num, set that equal to be range nums, and then we will do total, and to the total we will just keep adding the num variable, so total plus num, and at the end I will return total. And I forgot to set the return type, it will be int, so we can do like this, create a new variable, we call it sum1, and we set that equal to be sum, and then we can pass, for example, 100, 15, 20, 5, 7, and let's print out the result of sum1. It should be a comma here. So if we run this, you can now see that it have added the sum of all these numbers. Another example, let's create a new variable, sum2, and we set that to be sum. But here we can also pass a slice. So let's create one here. We call it numbers, and we set it to be int slice. So for example, 5, 8, 10, 20. And then we can call this function by doing numbers and then writing 3 dots. This will unpack the slice and pass every element as a separate argument to the functions. We can then print out the result, so fnt, print line, sum2, and now if we run it, we get 147 from the first example, and then we get 43 from the second example. Just in case, if you think this syntax looks a bit funny, just remember basically all the arguments you pass in will be turned into a slice here, and then you can just loop over that slice. And here is the opposite. We pass a slice, and Go will then unpack this slice and pass in every element as a separate argument. Go also have something called anonymous function. And that is a nameless function that you define inline. You can call it immediately, or you can assign it to a variable. Let's create one here, func, and then we can do fmt print line hello, and we can call it immediately by just adding 2 parentheses after it. So like this, if you would run this, you would see hello on the screen. And as I said, you can also assign it to a variable. We can create a greet variable, and then we set it to be equal to that function. And now we can call this function, so greet, and we run it again, and we get the same result. I want to give you a more advanced example when you can use this, and that's, for example, when you would use something called a closure. So a closure is a function that remembers variables from its surrounding scope, even after the function has returned. Let's see how that will look like. So we can create a function, and we will call it counter, func, counter. And this counter function, it will return a function, so func, and the function that will be returned will return an int. So we can start by creating a variable called x, and we set it to 0. And then here we will return an anonymous function. So return func, and this function returns an int. And then inside the body of this function, we will increment x with 1, so x plus plus, and then we can return x. So in the main function, we can create a variable and we will call it increment, and we set that to be the counter function. So counter, and then we call it. It looks like I misspelled it. It should be counter. Remember, when calling this function, it will return a new function, and this function will have access to the x variable. If we do like this, fmt print line, and now we call increment. Let's call it a couple of times. So increment again, one more, and then let's say one more time. And now if we run this, one cool thing with this is, as you can see, the increment function will remember the value of x between every function call. And this is because of closure. Go allows you to name your return values. This creates variables that will be used as return values. The initial value of a name return value is an empty value. So int is 0 and string is empty string and so on. So we can create a function here. We will call it func add, and we will take two arguments, a and b of int type. We return an int argument, but here we will give it a name, sum, and we set that to be an int type. And then inside we can do sum equal a plus b. And now because we have a name return value, we can do this, return. And this is a blank return statement. So Go will automatically return the name return values when using blank return statement. So we can try to run this and add, what's that, 5 and 2. Oh, I forgot to print it out. fmt print line. And let's run it again. So we get 7. And if we remove this line, remember I said before that named return values will be initialized to 0 values. So if we run it now, it will return 0. However, my advice is just to use this syntax only for simple function, or some would say don't use them at all, because if you use it for more complicated functions, it becomes very hard to read and it becomes hard to keep track of the data flow. And because they are initialized with their 0 values, you also run the risk of returning unintended results. So let's create a more complicated example and you will see what I mean. Create a new function and let's call it complicated function. Take two arguments, a and b, set it to be int type, and then we will return two named return types, so result, and that will be an int, and then an error of type error. And inside the body, do a check if a is less than 0, and we assign error to be errors.new a is negative. And then we can do result equal a plus b. If result is bigger than 100, we set a new error, set that to be errors.new too large. Then do a blank return here, and it should also be a blank return here. And then in the end, we can do a blank return here. So if you try to read this function, I found it very hard and confusing to actually know what the function is going to return. Like you have to read here, and then you kind of have to go up here, and then you have to go back, and yeah, for me it's just a mess basically. So as I said before, this is why some developers in the Go community say you shouldn't use blank return statement with named return values at all. It's just confusing. But of course, that will be your decision. My advice is if you're gonna use it, just use it for very simple functions. This is the end of this tutorial. So functions in Go are very flexible, allowing you to define reusable code, handle errors, and pass or return other functions. They help you make your program clean and maintainable. I hope you liked this tutorial. See you in the next one.